So, so the technology within Ignite that I was looking at to do this when I did it a little while ago is called continuous queries. So just a quick show of hands, who has used Apache Ignite or GridGain? Okay, a couple. Okay, so of those two, who's used continuous queries? Okay, so everybody's going to learn something. Awesome. So a continuous query is some code that you run that registers a query with the database. And so that the database is going to give you notifications when changes occur. So you can specify a bunch of different stuff. You can say, okay, do an initial query to tell me what the status is now. You can give the database some filter logic so that you minimize the data coming across the network. All of this kind of knobs you can pull. And you can run different types of queries, and you can have these filters actually execute on the database node itself. So this becomes very, very efficient because we can narrow down both the rows and the columns of data that we're interested in with actual Java logic if it's something you can't happen to specify in a SQL query. So then you write an app that loads these pieces of code into the database, and that app has its listener that runs local to itself. And we can pass data around in several different ways with Ignite. We can pass serialized Java objects, or we can pass binary objects. And the advantage with serialized Java objects is that they appear in your app, ready instantiated, but there's a cost to using them. You have to make sure that all the nodes that are sharing these objects have the same class definition, and you have the time to serialize the objects onto the wire. What I found when I was working with this stuff was that there's an option called binary objects, where you basically say, instead of saying, here's a Java object, you say, here's a string, or here's, more properly, I guess, here's a byte array to share across the network. And in that way, we can get, say, a JSON encoding or something similar of a particular Java object. And we can also narrow down the number of columns we want to send across the database with these continuous queries. And I'll show you some how this works in code. So it's not super big, so I hope people can see. I'm not going to step through this tortuously. I'll just kind of hit the high points here. So we write this app that runs remotely from the database. And there's some preamble of setting up where our config file is that has some instructions on connecting to the database. But basically, this is the fun stuff. We connect to the database, and we say, keep everything binary, okay? We're not going to be sending POJOs across the wire. And then we say we want a new continuous query, and here I get to set my query. And what I'm going to do here is say, if the field with this name, okay, so this is parameterized, so I can pass it in on the command line, equals some value, then that matches the predicate. So you'll notice here that I'm kind of implementing this predicate, and it's Java code. So I could be doing anything in here. I could be evaluating some math expression. I could be comparing substrings or whatever. But to keep it simple, I just said, OK, this field matches. And here I'm saying, OK, sorry, that was the initial query. OK, so give me everything that matches this. And then in the remote filter, this is basically doing the same thing. So I could have different code here. But again, what I'm saying is, I want to return the value of the field that matches what I'm interested in. And this will all make sense once it's running. So don't get too hung up on code. And then in my listener, again, there's some boilerplate around the edges here, but what I'm basically doing is just getting this object out, and it's just a series of key value pairs, and I'm saying, okay, I got a cache entry, here's its ID, here's the old value, if it was an update, if an old value is available, and this process change is just going to show me the new value. Or that might actually affect some change in your environment. Okay, we're listening to these notifications for a reason. And once we've defined all these things, okay, all we're doing back here is setting up the query, right? We're doing query set the initial query set remote filter factory, and so on. We actually run the query, and if we've got any existing data, we can process it, and then we just have to basically keep sleeping. Because what's going to happen is all of those listeners and things that we just registered get called asynchronously. So our main thread just has to hang around, and in reality, your app would be doing probably something more useful than sleeping. But those little bits get called dynamically when things happen in the database. Okay, so let's have a quick look. So this is where I hope that everything's going to, let's just restart the database. And we can make it even bigger. Oops. Okay. So this is Ignite running. Oh, it gets me every time. I don't know why they do that. You have to actually end the slideshow to get to the window. All right, so don't worry about that. That's just Ignite started up. And here I'll need to do a quick reconnect. So I've got a city table here. With some data in, just cities and populations. And what I've got over here is an app, oh, that's better, is an app that I can run to say, I parameterize everything, so I'm saying, I'm interested in city and when the name is London. So I want to get an update whenever anything changes on a row with name equal to London. So we cross our fingers, and if it's happy, okay, I thought I told it to, okay, bear with me 1 second here. No, that should be okay. No, it should work locally. I had it working earlier on, just on localhost. But I might switch to the Wi-Fi and restart it. No. Okay. Let's put it on Wi-Fi. Spaces. Yep.
It just makes you.
Yeah, do the pop-up thing.
Yeah, here's the.
Oh yeah, I will need Wi-Fi for Salesforce actually. I usually have a few minutes to.
Yeah, this was like a dash.
Reverator, okay. 914028 56. Okay. Continue. Done. Come on.
Yeah, it gets over there. It should. Yeah.
There we go. All right. Let's try this again. Kill this guy. Let's see. Let's try. Okay, it's not complaining about multicast now. Ah, there we go. So it connected to the cluster, and it ran its initial query, which was just to say, okay, give me all rows whose name is London. So I've got the population data and the ID there. So now what happens if we, let's go to my cheat sheet here. So if we change an unrelated row, so change New York's population, so somebody was born, then it just gets filtered out. But over here, you can see this code. So this 3 hashes is my code. These are these filters that I installed into the database. So those were going across the 4 rows to see if they match the initial predicate. And here, evaluating cache entry event filter. So this is what said, no, that doesn't say London. Okay, but now if we change the query to London, then go across here, then we say cache entry with ID 2 was updated, old key 2, population ends in 92, new population ends in 93. So this is pretty interesting now. I've got actual compiled Java code running within this database, performing actions in real time. So we can, let's go back to the slide for one more slide. So that's the basics.
Question.
Yeah, sorry.
In that example, if that data had an updated occurred that didn't change any data, would you still get the update? So if you just
Let's have a look.
If you just reset the data to the same value?
You don't. I'm almost 100% sure. So if we just repeat that last one, then oh, we do. Yeah, we do. Yeah, so it counts as an update in the database, and it goes across. But don't forget, my code here could look for that and not bother broadcasting it across the network. That's the nice thing here. So I guess we get the opportunity, but my code's pretty simple. It doesn't take it, so I do get the update. But I could stop that from even hitting the wire. That was a good question, actually. I hadn't tried that. Okay, so now, what's this transformer thing? So we just supplied an initial query, a filter, predicate, and a local listener. Now we supply a transformer. So this is where we really get to grips with the data. So again, this is remote code, so we set this in the query to say, rather than just returning the entire row, because in a real-world scenario, we could have 1,000 columns in our table, just return the thing that we're interested in. And this is where I said, okay, you could return a JSON encoding or XML or whatever you like. Here, we're just returning the value of whatever field we're interested in, translated to string. So in my local listener, it's not going to iterate through any key value pairs. It's just going to print out, hey, this is the string that I got. And then it's a fairly unsurprising demo. If I go back here, run my other example, which is filter to only see the population. So really, I'm only interested in the population. There could be 1,000 other fields that describe a city. Okay, all connects happily. Okay, that's the current state. So if we update it again, so somebody else was born in London, then all it says is, I mean, it knows what this field is because I told it on the command line, and that's all that came over the wire. So 7 characters rather than however much happens to be in the database for that entire row. So a really powerful feature. that you can use with this in-memory database to listen for updates as they occur. So you could compare it with a traditional database. You could compare it with a trigger or a remote procedure. Okay, so my key learnings from this. So this is great because if you try Ignite, you'll get some use from this. You have to remember to turn peer class loading on. So this basically tells the database that it's going to be loading Java classes across the network, bits of Java code. By default, when you create a table in the SQL tool, you've got to say SQL public city, so it's just like constructs this name, and you can override that, explicitly saying when you create the table. Okay, when I talk to it in code, the cache name, if you like, what I need to put here, just wants to be city or whatever arbitrary string you want. As I said, binary objects make your life simpler and faster. And yeah, after I'd figured out almost all of this on my own, I found the code example online. So actually, I learned a lot in the process, but then I found that almost exactly what I'd done was on a GitHub page. So read. Okay, so now I've kind of talked a little bit about the generic function. I'm going to talk about StreamSets, and I'm kind of, because since we're running low on time, I'm not going to talk about this diagram at all, except for we connect to lots of stuff. I like to describe this as a Swiss Army knife for data. I've got 40 or 50 sources I could connect to, 40 or 50 destinations. I can do a bunch of transformations in the middle. And I can do a lot of stuff without writing code, but I can start to write some code if I want to. So here is what I can create in Data Collector. I get a canvas to create a data pipeline. I drag these stages on, representing a data set of different operations. So here I'm reading a CSV file, deleted file, assigning each record with a unique identifier, converting some fields from strings into, I think it's a timestamp data type, and I'm filtering on fault code. This IoT data has a whole bunch of zero statuses, which means, hey, I'm here, but nothing's happening. I don't want those going into my real-time database taking up space because they don't mean anything. It's just situation normal. And then the ones that pass the test, I want to change those kind of inscrutable digits, 0, 1, 2, 3, 4, into actual code words. So information, warning, error, fault, and so on. And then I write the faults to Ignite through the JDBC driver. So I can get that data into the database. And that lets me do queries like this. So down the line, I'll be able to just select data out of the database. So the JDBC driver, the one I selected that the documentation kind of guides you towards is called the thin driver. And it's called that because it connects to one of the nodes of this distributed database, but it itself is not a database node. It's just a client. So it's very lightweight in terms of footprint on disk and memory utilization. So you have to, who's used JDBC? Okay, Java programmers. So you just have to make sure this jar is in your class path and reference, if you need to reference the driver by its class name, that's what it is. And then you can connect using JDBC URL. It says Ignite thin and the host name you're connecting to. So that's the host name of one of your nodes. Now, there is a bug I reported in Ignite, still there, that when you connect through the JDBC thin driver, all your table and column names have to be in uppercase. So in regular SQL, talking to Oracle, MySQL, whatever, you can have whatever case you like, but yeah, you just have to, even if you define the table with a lowercase name, it has to be uppercase going through the JDBC driver or things break. Now, there is an alternative. There's what's called the JDBC client driver that actually starts its own node of this distributed database. Now, there's kind of trade-offs between the two. The client driver is more mature, but and you may want a local copy of the database close to your application, but then, of course, you're paying the price in terms of storage, either RAM or disk. So for us, integrating into an existing tool, it was very valuable to have this thin driver. Okay, so let's see if the demo is going to work. So I don't trust this thing now. All right, so it's gone all weird because of the resolution. Here we go. So I'm going to read a file from disk. So it's in my device faults directory. I'm going to read any CSV files. And I'm assigning a UUID. So basically, I'm just saying the ID field is a new UUID. I can evaluate expressions here. I convert timestamp to a date time. So I specify the format I'm expecting it to be in. And then I say, OK, if the fault code is greater than 0, then I'm going to pass it along this way. Otherwise, I'm just going to discard it. I'm not interested in status OK kind of messages. And then here, I've got a static lookup that I set the fault code field. I look at the fault code field, and I set the fault field. And here, I've literally just got 4 different values. But there are other lookup stages that go to a relational database or Redis. So you could be enriching the data via any mechanism you like, as well as filtering the data. And I can check that everything's OK. So this makes connections checks that the directory is there, makes a connection to the database. And I can also preview my data. So this is going to read the first 10 rows of that file on disk and show them to me. So here, the serial number here, the timestamp, the fault code, and it gives me some metadata here. So it actually tells me the file it was read from and the offset into the file. So if we look at the second one, we can see that's offset 63. So this is your data lineage. As data passes down the pipeline and into other systems, you can actually be able to track it back to exactly where it came from, literally the byte offset into the file. And what's really nice here, although in this resolution it's a bit crappy, I can step round the pipeline. So here I can see that that UUID was assigned, and then these 2 fields were converted to date, time, and integer. And then I can see that this record was sent to stream 2 because it hit the default. And oh, look, there's one that matched the condition. So that matched that condition, so it's sent to stream 1. So when we can click there and we see, OK, here's all discarded data. Here's the lucky record that made it through the cut. And that's what would be written to the database if this were not a preview. So this is a great tool that when you build a pipeline, you can get confidence that it's acting how you expect. OK, so let's just reset the origin because I want to read right from the beginning. I've run this before. So, and if I hit start, then we cross our fingers, then, yeah, it's read 86,400 records. Any guesses why that's the number? 86,400? Come on, room full of nerds. Number of seconds in a day. So we've literally got a reading for every second in the day. Anyway, I used to work with time series data, so that number's burned into my brain. So the data should be in Ignite. So now we can go to Ignite over here and say select star from fault, I believe it is, limit 10, because we don't want all 86,400. So we got the first 10 rows. You can see date, they're all critical faults or errors. So we've filtered it down to what we're interested in. And if we say select count star, whoops, learn to type, from fault, we can see that out of those 86,400, there's only 881. And we can actually see that if we go there. You see that's that 881. So this is really neat. And you'll notice that this pipeline is still running. Okay, we read an input file, but this is a live pipeline. So what we can do is go back to our command line here. Where should we go? This one. And if we move this hidden file and make it end in CSV, it'll match the wildcard. Now, if I go really quick, whoops. This is scanning the disk every 3 seconds. Oh, there it goes. So it just went from 86,400 to 172,800. And then we go back to the SQL, and we see that now we have more data in the database. So everything's working nicely. So this data, this pipeline, this whole system is designed for these pipelines just to sit there and run continuously. So you can imagine some IoT platforms dropping data files into the directory, and this is just picking them up and putting them into the database. So very, very simple. Okay. So let's get a little bit more realistic and have fun. So here's the architecture. Now, this use case falls into a category called master data management. Okay, we're bringing this data together from several master systems. So rather than looking at files, I'm going to say that Kafka, the message streaming platform, is our source of truth for IoT data. Okay, a bit more realistic than flat files. I'm going to say that MySQL has our HR database. So that has the reporting structure of all of our support engineers. And Salesforce has our support cases. I'm going to whiz through this because, is it hard stop at 8 or are we? Okay, we have a little bit of flexibility. I'll go reasonably quickly, so if it's not making, then shout, because I'm looking down here. So let's ingest some data. So if we stop the CSV pipeline, and then we don't have to wait for it to stop, we can say Kafka device faults to Ignite. So you'll notice that this is almost identical. In fact, the one and only difference is that we connect to Kafka rather than the read from a flat file. And this is an example of what we call data drift, that our sources of data change over time. We stop getting data from flat files and start getting it from Kafka. We encounter new fields in the data as we read it. And this is something that we focus on a lot. So literally, I created this by just copying the old one, deleting that, and replacing it. So everything else is identical. And I've parameterized this so that you could. It's like taking configuration out of the system. What I could run it by specifying the parameter here and change it to something else. But the default's good for me. So I'm going to start that. And if it's all happy and it connects to Kafka, it should say that it's, well, I think it's running. OK, so let's delete the faults that are there, because we want to start with a fresh. OK, so 0 faults. OK, we started with a fresh slate. And I can push a great number of faults. I can push those first 86,400 in one go. So there's 86,400 greater than signs. And it's going to scan through those. And it actually takes a little bit longer because we're feeding them through the messaging layer rather than just pulling them from local disk. But we still get those, and it all happens the same. And I can illustrate the streaming manner a bit better by running this script on the second file. And this actually just writes a few every second. So we can see this ticking up. And then if we go across to the database, we can see that the count just goes up. Well, should be going up continuously. Maybe there's just a whole, most of the data is zeros, meaning nothing's happening, so we have to wait a few seconds. There we go, 885 to 889. Okay, so we've got our fault data arriving from our devices out around the world. We need our employee data. So I've got a database here with employees. So if I go to my SQL and say use HR, what the heck? Use HR, select star from employee. So we've got, obviously a real HR system has much more than this, but we've basically got ID, first name, last name, manager ID. So the CEO has no manager, and then titles. So then if we look at the title table, then obviously this is relation database, third normal form. It's all, there's no redundancy. We've got these 4 different titles that are assigned to our, 17 employees. So again, we want those into the database. And what I'm going to do here, because I don't want to navigate different tables in Ignite, I'm actually going to just join them in the query. So I specify when I read from a database, I can specify a query. So I'm saying here, select some columns from the employee, left join on title, where the title ID equals the ID in the title table. So really basic stuff. And then writing that data to Ignite again. Now, this is a pipeline that we might run daily. Okay, HR data is not quickly moving. We probably don't want to be polling the database continuously, taking up resources. So this is, if you like, a batch operation. So we say, okay, when the no more data event is received, stop the pipeline, or when it's emitted rather from the origin, stop the pipeline. So again, just reset this, make sure that it starts from the beginning, and well, it just finishes almost as quickly as it starts because there's only 17 rows, but I can see here that 17 were ingested and 19 emitted because 2 events went to this guy here. There was a finish the table and then no more data in the entire query. So now if we go over, we can do things like just check that, whoops, wrong database. Oh, that's happily going away. We can check that our employees are in Ignite, and we can start running SQL queries. So the usual kind of thing. So who reports to Hannah Bates? Peter Preston, Michael Sinclair, and Mitchell August. And let's read in the Salesforce data. So where is it now? Cases. So I've got these cases in Salesforce. Again, it's pretty much the same. I'm not doing much transformation of the data here because I'm just lifting and shifting. But again, I'll just reset the origin. Yes, close, go. And so this one, there's 8 support cases there, but it's another live pipeline. It just continues running. And I can say, okay, which managers have engineers working high priority cases? So this is literally information that you could not get from either of those systems, from the HR system and from Salesforce. You have to join it together somewhere. And here we're joining it in Ignite. So I can do that and see Kim Park's got 2, Hannah Bates has got 1, and then I can go to Salesforce. So go into my recently viewed cases, and if I make another of them high priority, so BKG flame not lighting, let's change that one. So high priority and then save. Then we can go over here. We see that went to 9. And, well, oh no, I've got to copy that whole query. Now, Kim Park has got 3 high priority cases in her department. Now, I'll show you one quick little feature while I'm here. I can capture a snapshot. So this is a running production pipeline, okay? We don't want to interrupt it. It's going along, but we're not sure. There might be something going wrong with it, so we say capture a snapshot. So then the next change that comes along, maybe this one changes to high priority. Whoops. It actually scoops that batch of data out. And again, we get to see exactly what's in it. And again, we could step around and see, follow it around the pipeline, but this isn't that exciting a pipeline. But I can see everything to do with that data and the metadata. So we now have data from 3 systems in Salesforce, and I'm ready to show you what you came here to see, which was the continuous ingest. So let's move along. A couple more slides. So there is a caveat here. There's a bug in Ignite that breaks JDBC integrations. So this is in the thin driver, so I'm like a pioneer on this for you. I'm getting the arrows in my back. But when you ask for the primary keys in a table, it lies to you and tells you that the column name is _key instead of what it really is. So I reported that. They fixed it in the upcoming 2.8 release, and I had to code a workaround into my custom version of Data Collector. So let's do this continuous streaming application. So we're going to listen for high priority service tickets, and when one of those appears, a new one, we're going to get the last 10 readings for that device. So in terms of the app, I specify a SQL query because I'm going to get an update on that cases table, and then I need to do a SQL query when that update happens to say, okay, here's the serial number I'm interested in. Give me critical and error faults in descending timestamp order limited to 10, and I just print those out. So again, let's just go, whoops. I need developer evangelist mode where it just switches the display automatically. So that's going to be let's kill this guy for a minute. Okay, so if we CD, I should have had an extra window open here, so I don't have to do this. If we go there, and then, so this will be demo 2. So this should listen, connects, and so it's connected to the cluster, and it's waiting for high priority cases. Okay. So what's going to happen is I'm going to change it in Salesforce. StreamSets is listening to those changes. Salesforce has a protocol to listen for notifications. Salesforce is going to update Apache Ignite database. Then my code that's running, listening for changes, sees that changed case, and then performs a SQL query on the faults to give the user, to tell the user, A, there's a high priority fault, and B, here are the last 10 statuses. And with all of that explanation, it's so dull when it actually happens. So we change this to high, and then save, and then go back really quick. there was only one fault for that particular device. Let's see if we can pick another one. Hi, save. Oh, none for that one. Everything's been really reliable. Hi, save. Okay, it is working. It's usually this one that I change, I think. So medium, save, change it back to high, save. There we go. So this one had one error, these ones didn't have any, and this one had 5. So we've actually built this monitoring system combining data from HR, from Salesforce, and from the IoT system. And we could fire off an email to the manager of that group to say, hey, a case that's been assigned to you is now transitioned to high priority. Get on the case. Oops. Okay, so rounding off in the 2 minutes I don't have. Okay, so that's one use case. We have dozens of customers. So data lake replatforming, fancy term for taking your archive data out of some expensive place like Oracle and putting it into a cheap place like Hadoop. That's a big use. IoT, we've already mentioned. We've got one user doing a really interesting cybersecurity and real-time application where he's analyzing firewall web server logs in real time, looking for suspicious patterns of activity, okay? So they've got machine learning, looking at patterns of activity in incoming firewall web server logs. And then when they've identified some suspicious pattern, they actually reach out and change the Amazon firewall rules in real time. And he said that it's about 10 seconds from activity being detected to changing those firewall rules to maybe exclude that IP address from any further intrusion attempts, I guess. The thing with the cybersecurity is that they never really tell you exactly what they're doing. They're always a bit vague. And then we've got like some great customers. So GlaxoSmithKline bring together their global research data into a single data lake with thousands of data pipelines. It's a very segmented, siloed environment that they have. eTrade has implemented this to bring together, again, security log data from disparate systems into a single location for analysis. And then CBS, the broadcaster, has used it for revenue, quality control, and ad inventory. So, again, an analysis use case deriving value from the data that's kind of already there. All right, so wrapping up. These